Okay, so hi there folks, we're now on our continuation video in college algebra, and we're going to talk about today and continue our talk rather, our batch of videos in exponents and radicals. So we're now here in the fractional exponents, wherein we're going to see now exponents which is in the form of a fraction. Okay, now using the laws of exponent or the law of power over product, um, or product of powers, I can't remember the name, but using laws of exponents and multiplication, let us take the expression here. So we have 25 raised to this number, which is a half, times 25 raised to a number, which is a half. And we have this law, maybe law of a product or product of a power. That is, if the bases are the same. So we can see here the base, which is 25, and the base, which is 25. So we can therefore add the exponents if provided the bases are the same. So since the bases are the same, we're going to add exponents, which is a half plus a half. So we know a half plus a half is equal to 1. So it's like having 25 raised to 1, which is it's okay not to anymore write that. So that's we have 25. Simply we have 25. So what does this show us? That this 25 raised to 1 half. Okay, what this shows us is that this certain, okay, in a moment, this certain 25 raised to 1 half, okay, this one is one of the equal factors of 25. So we say it's equal because 25 raised to 1 half is the same with 25 raised to 1 half. So they're equal. And these certain numbers give us a product of 25, or a result which is 25, meaning this 25 raised to 1 half is one of the equal factors of 25. Notice that one of the equal factors of 25 is positive and negative 1. So the plus, or rather, positive and negative 5, plus minus 5. It's the equal factors. The equal factors. Because 25 is equal to positive 5 times positive 5. It's also equal to negative 5 times negative 5. So meaning it's either plus or minus 5. So therefore, 25 raised to 1 half is equal to positive negative 25, positive negative 5 rather. So that's plus minus 5. One of the two factors of a quantity is what we call a square root. A square root of a quantity. Again, one of the two factors of a quantity, or one of the two equal factors, sorry, they should be equal. Two equal factors of a quantity is what we call a square root. This shows that 25 raised to 1 half means that it is a square root of 25. So in symbols, you write it as this. And we introduce now the radical sign. So hence, we define it formally that fractional exponents, such as this one, fractional exponents which can be written as this, a raised to 1 over n. Okay, again, a raised to 1 over n is equal to n, the nth root of a. The nth root of a. So if we imagine a raised to 1 half, we're going to look at something like square root of a. If we have something like a raised to 1/3, so what we're going to have is the cube root of a. Anyway, square root of a, we can write it, even without the minus 2. Okay, we can write it even without the minus 2, or the positive 2 rather. So when you say square root of 2, it's just equal of saying something like this. That is also still square root of 2. Okay, so that is a raised to n over here. The term here is read as a to the exponent of 1 over n, or a raised to 1 on n, is the principal nth root of a. Principal nth root of a. So the prime nth root of a. While we say that a raised to m over n, as we can see, it's not, the numerator is not a 1, but it's another integer. So a raised to m over n, a raised to m over n is equal to n, the nth root of a raised to m. Or it can be n the nth root of a raised to m. So where a raised to m is the nth root of a, the nth root of a here raised to m, raised to m. Okay, or the other way around, the a raised to m, or the nth root of a raised to m. Yeah, yeah, that's it, that's it. Okay, so for the exercises, these are our exercises here, everyone. So maybe you can pause the video and try to answer it themselves, or you try to answer it yourselves rather. Okay, so you may pause the video right now. Okay, so let's try to answer right now. What is or rather 8 raised to 1/3? So recall our formula. Let me write it here. Let's make it general. A raised to m over n is equal to the nth root of a, oops, sorry, the nth root of a raised to m. Okay, so if we're going to look at it this way, so we have 3 as our nth root, so that's the cube root of 8 raised to 1. So it's okay not to raise 8 to 1 because that's redundant. So what is the cube root of 8? Meaning what number? That is, we're going to multiply it by itself 3 times and it will give us 8. What is that? So you may think of 2 times 2 times 2. So 2 times 2 times 2 is going to give us 8, right? So 2 times 2 is 4. 4 times 2 is 8. So therefore, we say that the cube root of 8 is equal to 2. Okay? So that's the cube root of 8. That's for number 1. For number 2, what we have here is 8 raised to 2 over 3. So we're going to look at this formula here. So that's going to give us 3 cube root of 8 squared. So first, we're going to simplify the inner term. So by the PEMDAS rule. So what is 8 squared? 8 squared is going to give us 64, right? 64. Now, what number multiplied by itself 3 times is going to give us 64? You may pause and think for that. Okay, so we may try to check 4 times 4 times 4. So what is 4 times 4? That's going to give us 16. So 16 times 4, another 4, is going to give us what? 4. 4 times 6 is 24. And what we have is 6 times 6 plus 2 is 64. So indeed, 4 times 4 times 4 is going to give us 64. So therefore, we say that the cube root of 64 is equal to 4. So meaning we say that this is equal to 4. I forgot to say it here. So this 8 raised to 1/3 is equal to 2. Now how about number 3? How about number 3? So what we have is negative 32 all raised to 3 over 5. Again, negative 32 all raised to 3 over 5. So let's use this formula as always. So what do we have? 5 fifth root of negative 32 fifth root of negative 32 raised to 3. Okay, so the fifth root of negative 32 raised to 3. Now imagine if we are going to raise this to 3 first, that's going to be a big number. And thinking about that very big number, and then we're going to have the cube root of it, that's going to be a little bit tasky. So maybe we can rewrite it as this. This is actually equal to fifth root, oops, fifth root of negative 32 and then raise it to 3. Actually, they're equal, right, by the definition. So what is the fifth root of negative 32? So what number multiplied by itself 5 times so it's going to give us negative 32? What's that? Okay. If you're going to think just for a while, you're going to know that it's minus 2. Minus 2 times minus 2 times minus 2 times minus 2 times minus 2. So let's evaluate it one by one, shall we? Let's move the screen over here so that number 3 can fit. Okay, here we go. Okay, so 2 times 2, let's have this. Negative 2 times negative 2 is going to give us positive 4. Positive 4 times negative 2 is going to give us minus 8. Um, Minus 8 times minus 2 is going to give us positive 16. And positive 16 times negative 2 is going to give us negative 32. So you can see that our fifth root of negative 32 is negative 2. So this is going to be equal to negative 2 cubed. Now, what is negative 2 cubed? Multiply the negative 2 three times. So what we have is negative 2 times negative 2 times negative 2. So negative 2 times negative 2 again is positive 4. 4 times negative 2 is going to give us minus 8. So therefore, our answer here is going to be minus 8. Okay. Now, that's it for our videos in fractional exponents. I hope you learned something here. I forgot to write it like this. Oops, minus 8. Yeah, that's it. So thank you very much for watching. I hope that you will hit the like button and also subscribe. Okay, so thank you very much.